All right, so this video is going to cover this driver's license exam list program and this gradebook list program. So we'll start off with this one. It says a local driver's license office has asked you to write a program that grades the written portion of the driver's license exam. The exam has 20 multiple choice questions. Here are the correct answers. A student must correctly answer 15 of the 20 questions to pass the exam. Write a class named driver exam that holds the correct answers to the exam in an array field. Again, when you see array, this is Java, but we're working with lists, so in Python. But we can still write this. The class should also have an array field that holds the student's answers. So you're going to have like a driver's answers or correct answers and then the student answers, and then you're going to compare them. The class should have the following methods. Passed returns true if the student passed the exam, or false if the student failed. Total correct return the total number of correctly answered questions. Total incorrect returns the total number of incorrectly answered questions and questions missed. In an int array, so we got to create another array called questions missed, and an array contain the question numbers. So we need to do the question numbers, so that's the index of which ones they missed. Demonstrate the class in a complete program that asks the user to enter a student's answers and then display the... Okay, cool. All right, so I started writing this, and because this is a lot of typing that doesn't necessarily need to be in this video when you're watching this. So we've got the correct answers right here. First of all, I've got the index position that the correct answers are in. And then I have two students. One student who passed. The only one they missed was in position 2 and in position 7. So they put C and the answer's A, and then they put C and the answer's B. And then student 2, notice the X's are the ones that they missed. You know, for this one I just put C down the board. You know, sometimes when we're doing our standard testing at school, kids will just not want to do it and just put C. So anyway, they only got 1, 2, 3, 4, 5 correct. And so then what we're going to do, student 1 passed, and it's going to return true or false. And this is the pass method, so it's going to pass in the correct answers in the student 1 answer. It's then going to count up the total correct and total incorrect, and then it's going to spit out an array with the questions that were missed. And then same with this one down here, okay? So, I guess we'll start off with this passed method. So we'll just say define passed. And we got to pass in the correct answers and the student answers. Now look at this, student 1 answers and student 2 answers. When they get passed in, they just become student answers, that variable right there, that list variable. Okay, so we'll say global missed, and we'll assign missed to basically blank. We'll have a global correct, and we'll say that correct is equal to 0. We'll have a global incorrect, and we'll say incorrect is equal to 0. Now the reason why I'm making these global is because I'm going to use these in different methods, okay, or different functions, sorry. And let's see here. Let's make an I variable equal to 0. And so we've got to run through the correct answers basically. So while I is less than the length of our correct answers, you know, each time we go through it, we got to add 1 to it. And this is going to give our, right here, we'll do if correct answers at position I is equal to the student answers at position I. So like right here, correct answer, student answer. So in position 0, B is equal to B. So that's a correct answer, all right? So then all we do is add up our correct answers. Okay? And if they miss it, meaning that it's incorrect, for instance, this one, is B the correct answer equal to C right here? No. So then we do incorrect equals incorrect plus 1. And then for this one, remember we have to build a missed list with all the missed ones at their current index position, okay? So when you would get your test, you start off counting at 1, right? 1 through 20. You wouldn't start off at 0, all right? So the missed ones are going to be, let me think here. We're looking at the index position, so position 0 is really position 1 in real life. Okay, so we need to say missed and then append it to this new one, okay, I plus 1. Now, this is kind of nitpicky. You could just set it equal to I, and then it would give us index position 0. But by saying plus 1, it's going to give us what number it is, okay? Again, nitpicky, you can do this however you want. It's not that big of a deal. I mean, it's just practice, just so that you know what I'm doing there, why I did that, okay? Because I want to say, oh, they missed number 1 and number, 20 or whatever. But in 1 and 20 on here are actually position 0 and 19, okay? All right, so then if correct is greater than or equal to 15, then we return true. Else, we return false. Okay, so that should be good. Now we've got our correct and incorrect and our missed. So now all we can do, we can do define total correct, and we can return the correct answers. We can define total incorrect. We can return the incorrect answers. And then we can define our questions missed. Yeah. And then what return missed. Sorry, there we go. So let's run this. I think it should work, hopefully. All right, so there are 20 questions. Remember, this first student only missed 2 that we can visibly see, and so total incorrect is 2. Which ones are those? 3 and 18. Well, remember I did plus, so question 1, 2, 3 right here. Question 1, 2, 3 they missed, which is really index position 2. So, again, we're getting into nitpicky stuff here. It says an int array containing the question numbers of the questions that the student missed. So that'd be the question. It didn't say index position. So again, you could just get rid of this. I can show you right here. I could run it again. It's the same thing. They missed question number index position 2 and index position 17 right here. So, again, it's coming down to nitpicky stuff. I don't really care. I'm just trying to show this to you. And then this second student here, depending on which one we're looking at, they only got 5 correct. So 1, 2, 3. 3, 4, 5. You only got 5 of them correct. And the questions missed were in position, you know, all the ones that they missed, all right? And so we got that. So 19, 18, 17, 14, 13, 12, 10, 9, 8, 7, 6, 5, 3, 2, 1, 0. Okay, so yeah, this looks good. All right, cool. So the next one, and again, I wrote a bunch down because I just did all the people in our what we're gonna do here, so I didn't have to type all that out and waste your time watching the video. So let's see here. Grade book. It says a teacher has 5 students who have taken 4 tests. The teacher uses the following grading scale to assign a letter grade to a student based on the average his or her 4 test scores. Write a class that uses a string array or an array list object to hold the 5 students' names, an array of 5 characters to hold I might have messed up what I was thinking about doing, but I can do that as well. It holds their letter grade. 5 arrays of 4 doubles to hold each student's set of test scores. Class should have a method that returns a specific student's name, the average test score, a letter grade based on the average. Demonstrate the class in the following. Demonstrate the class in a program that allows the user to enter each student's name and his or her 4 test scores. Should then display each. All right, so I'm not going to make this dynamic where it asks you, please enter student 1. Please enter test score 1 for student 1, test score 2 for student 1, test score 3. That's too much data entry. That's, you know, they got 4 tests each times 5. That's 20 different items I have to type in. So I'm not doing that. Wrong one. So what we will do though is so we're gonna have 5 students and 4 test scores. Actually, you know what I even did? I think I did. Yeah, okay, cool. This is fine. All right, so let's do this. We're going to define set name. And we'll have a global name. List. And we'll just say Jane, Joe, Jill, Jim, and Jack. So we need to do a set name so that gets set there, all right? Because we can't get the name until it's set, all right? All right, so we're going to pass in these different names, okay, to see if they... So for the first one, there isn't somebody with a blank name, or we could even say, I don't know, we're doing Johnson, okay? This person's not going to exist because they're not in the, you know. So we set the name. We're going to set the name right here, and then we'll get the name. So we're going to do define get name. Only we got to pass in what the name. And so we're going to do some with a global index. Okay, and then we'll say I equals 0. index is equal to -1. -1 means that the student doesn't exist in the name. Okay, so while I is less than the length of name, and I'll show you here why I did this. Okay, if the student name, and I think I did this here too, student name, if the student name is equal to the name at position I, so we're checking to see, is Johnson at 0, then 1, 2, 3, 4. It's not, but if it was, index will be equal to I, and we'll return the name at position I. And if it doesn't exist, then we got to do I equals I plus 1. So Johnson right here is not, this needs to be a student name. That I did that student name. No. We're running through not the student name. We're running through the name field right here. I got that mixed up. So Johnson gets passed here, and then the name field is global, and it's equal to that. So I is 0, and it's less than the length, which is 1, 2, 3, 4, 5. So if the student name Johnson is equal to the name at I, which is Jane, it's not, then you would set the index to I, and you would return the name at position I, which would return Jane right here. But it doesn't, so then we got to go I plus 1. So then we're going to compare Johnson to Joe, then Johnson to Jill, then Jim, then Jack. And for all of these ones, they work, but this one doesn't. So we got to set up a test case where it doesn't work, so we can return false here. Okay. So if we get through all of this and we are not able to return a name, then we need to return something, and that something will just be student does not exist. Okay. So the student does not exist. All right. Okay, so now we've got to set up our tests. So if I were to run this again, yep, it's not setting it equal, it's checking for equality, so run that. You need double equals when you're checking for equality. So Johnson does not exist. Jane, Joe, Jill, Jim, Jack, okay? Alright, so now we need to set the tests. Set tests. Define, and this is what I was saying, I'm not gonna, you know, we'll do a global test 1, test 2, test 3, test 4, and test 5. So we'll say test 1 is equal to test 2 is equal to test 3. All right. Now I'm just going to populate it with a bunch of different data, okay? Again, I'm not going to ask the user to type this in. Testing too much becomes kind of a nightmare, so especially for these, and this is kind of why testing at the school level just doesn't do you justice, because that's what you would actually be doing in the workforce. If you got a job programming, you spend a ton of time testing, which isn't the most fun, I guess you could say. but it's absolutely necessary because you can't have, you know, end users breaking your code. I mean, that won't fly at all. Okay, and then 25. And I think what I did is each of these students on here earn a different test grade, so that, you know, it can be tested, or you can test each one to make sure it works. So that sets our tests. Now, next thing we gotta do, once our tests are set, we can do things like figuring out the average and then the letter grade and so on and so forth. So let's do the average next. This should be pretty easy. Okay. So what do we got to do? Set average. Or we can just do get average. Define get average. So we'll say global average, and average is equal to 0.0. Okay, we'll say if index, now remember our index up here, if we find the student, if the index, it's gonna give us an index number if we find the student. If we don't, index is -1, all right? So if index is not equal to -1, then the average is equal to our test 1 at the index plus test 2 at the index plus test 3 at the index plus test 4 at the index plus test 5 at the index position, all divided by 5. Okay. So if that, then we figure that out, and then we return the average. And if we don't find it, else return 0.0. So all these are in parallel. Okay, so Jane's tests are all here. Joe's tests are here. Jill's are all here. Jim's are all here, and Jack's are all here. Okay, so let me think here. No, I don't want to do this. I don't think I did it. Yeah, test 1, 2, 3, 4. Yeah, I think I did this right. And I'm getting kind of a brain. Okay, cool. I think that's right. So now let's run it. Okay, Jane's average. Let me think here. Let me think. I think I screwed this up when I did this, when I was thinking about it. So, let me think here. We could probably still use it though. So like 75 plus 25 plus 65 plus 35 plus 25 divided by 5 gives us our 45 average. So that's test 1. That's the average of the class. Now, let me think here for a second if we can use this, or if I have to change it up. So I'm going through this, and ideally I would use a two-dimensional array right here, but that's not really part of the course scope. And so I kind of remember why I did it like this, even though this is probably not how you'd want to do this. So ideally, your data, if you did it like this, notice how... So I talked about parallel arrays in a previous video. This is index position 0, 1, 1, 2, 3, 4. You know, and then same thing here. Index position 0, 1, 2, 3, 4. Okay, so Jane's scores are the first score in test 1, test 2, test 3, test 4, test 5, and then, you know, so on and so forth. Like Jack's are all index position 4 down here. So Jack's average is a 90. So, you know, average of 180, 100, and then 80 is 90, and 90, 90, 90, and 90. That average is going to be 90, okay? So Jack got an A. So, again, this works, and I just kind of had a brain freeze. But I don't know. This works fine. Maybe I'm just thinking into it. I mean, the data does work. Jane, on hers, got 45. You just have to set this up properly, all right? So, get letter grade is next. So what do we got? Define get letter grade. Notice how the student doesn't exist. They got a 0.0. Okay. So we'll have a letter grade equal to blank at first. And we'll say, you know, if average, which remember is global, so it sets the average in here, and I can use it down here. If the average is greater than or equal to 90, then the letter grade is equal to an A. L if average greater than or equal to 80, letter grade equals a B. L if average is greater than or equal to 70, letter grade equals a C. L if average greater than or equal to 60, letter grade is equal to a D. And then finally, what else? It's equal to an F. Then we return the letter grade. Okay. Run that. So this student didn't exist, and they're just automatically have an F. Jane has an F. Joe has a D. C. B. A. So, I don't know, a little different than maybe what I should have done here, but again, the only thing that's weird is this is the array of test scores. I don't know, again, I think this works fine. I just was thinking in my mind when I was writing this out that test 1, yeah, no, this is how it should work. Because we find the index of where their name is, and then the index of where their name is will match up with the index of their score on each test. So this works. Again, ideally, you should just have one 2D array, and then you'd have, you know, all these single arrays inside the 2D array, and then you only have to have one variable. But that's for, you know, probably a more advanced class than what we're doing here. So Anyway, this video is done.